I am an academic engineer. I spent most of my career in academia at the University of Southampton, although I did spend about 10 years in industry prior to that. My specialisation in engineering has been around sound and vibration, and so I was formerly director of our Institute of Sound and Vibration Research before I became Pro-Vice Chancellor at the university. Sound and vibration is a great subject because not only does it have lots of fundamental physics in, but it also impinges directly on so many engineering activities. So I've worked in a whole range of different industry sectors, from aerospace and defence through to construction and through to audio engineering. Engineering and physical science really underpins so much of our economy. Basically, technological progress really drives economic growth. So it has huge impacts on the economy and industry, but also on government. The fact remains that government spending on things like healthcare and defence and so on and so forth, all the big budgets that the government has to really invest in, a lot of our disciplines can help our government act more efficiently as well. So I think that we can really have a two-pronged approach to this, not only help drive industry, but also help government reduce its costs. I think the most important challenges for EPSRC over the next 5 years really are maintaining the sort of forward momentum that we've got, because I think engineering and physical sciences in the UK is in a remarkably good state of health, and it's managed to preserve a great standing internationally in the quality of the research it does and in the impact that it generates on industry, society and the economy as a whole. And I think maintaining that position is going to be a tough thing to do because budgets have been squeezed. We've been extremely lucky to have had the ring fence in place over the last 4 or 5 years. But the fact remains that we're still way behind many other nations in terms of the amount we invest in research in engineering and physical sciences. And I think it'll be quite a challenge to ensure that we still keep the quality up, still keep delivering impact, whilst our budgets are constantly squeezed. The underpinning notions behind the plan haven't changed that much. The vision, for example, is simply for the UK to be the best place in the world to research, discover and innovate. It's as simple as that. The goals, again, follow very clearly from the vision. Number one goal is to research and discover. History has shown that so many of the great discoveries over time have come from scientists really being well funded and being unconstrained in the work that they do. The other goal we have, of course, which is absolutely relevant in the modern age, is to research and innovate. And by that I mean transform those discoveries into real world-beating innovations that have real impact on the economy, that really do deliver economic growth, that really do change the way the world is in which we live. We have 3 clear strategies for delivering our 2 goals. One is to balance capability, and by that I mean that we need to be able to ensure that we have a broad spread of work going on across all the relevant engineering and physical sciences disciplines, those underpinning sciences that we have. So that's balancing capability. The other thing that is particularly important to us is, of course, building leadership. So many times you can see it's those leading researchers, all those research leaders, we need both, that can actually deliver real value in their research groups through the work that they do. And we're really here to encourage both those academic leaders and, of course, to develop the leaders of the future through our PhD training programs. The third strategy is about what I call accelerating impact. And that means really taking those great discoveries that I talked about and really moving them into the marketplace as fast as we can to ensure that we pick up on new discoveries, new technologies, move them very, very quickly into practical applications. What we'll be doing in the next 6 to 8 months is, following the publication of our strategic plan, is to put together our delivery plan. And what that will be is a much more detailed account of the sort of work we'll be funding following the fact that we've set our high-level goals. So we'll be going through a process of consulting with the community, working with our strategic advisory teams, our strategic advisory network, and of course our council, to decide the balances we might strike between the underpinning capability themes that we have and any other themes that we might focus on the challenges that face society today. Some of the topics that really have emerged over the last few years that we really feel need concentration on and funding for are things like quantum technologies, for example, where things are now happening at such a small scale where we can exploit remarkable facets of quantum physics and really turn them into workable technologies. One is secure communications. That's something that holds out great possibilities. Another, of course, is quantum computing, where quantum computers hold out the possibility of really solving some massive computational problems that really just are impossible to solve using classical computers. Another really exciting thing that's happening is around big data, so-called. I mean, the world is generating data at a rate that's astonishing across all sectors, from healthcare to engineering to information technology, obviously, and the commercial sector. Everyone is interested in analysing and understanding massive data sets. And so we're in the process of setting up something called the Alan Turing Institute to really be a national centre, a national focus for the way that we exploit big data. Other things that are happening include a big initiative on robotics and autonomous systems. Again, the future in terms of driverless cars and robots that can investigate the seabed. Another initiative that we've recently launched has been a whole raft of grants that we've put out to our community to really tackle the problem of early diagnosis of dementia, and actually having an early diagnosis and technological means of helping GPs in the surgery come to a rapid conclusion onto whether there's something to worry about here is really a great contribution that our engineers and physical scientists can make to healthcare. And again, that will have big implications for government spending and the economy as a whole. All these things are really exciting prospects for real impact on the world in the next 5 to 10 years.